technical presentation, commercial presentation, and I would like to thank Gemología for inviting us and giving the opportunity or the platform to present this hopefully informative and entertaining presentation. So today I would like to talk about synthetic diamonds and their identification. That's it. So perhaps most of people know HRD Antwerp, but I would like to briefly introduce what we do, where we are based and things like that. Then introduce synthetic diamonds and their recent developments for the past 5 to 10 years. Talk about screening and detection methods, but especially what you can do to detect or screen out those potentially synthetic diamonds, if you want to refer them. Talk about screening instruments, D-screen, diamond shore, and then introduce you the brand new alpha instrument, the alpha diamond analyzer, and then present or conclude with an outlook. So HRD Antwerp, we're based in Antwerp, one of the world diamond trading centers for rough and polished diamonds. Our main activity is providing certificates according to the International Diamond Council. We're ISO accredited lab. But besides polished diamonds, we also offer services to gemstones and jewelry reports. On the other side, very important as a service to provide besides the certification is to offer workshops with respect to certification, how to sort out rough diamonds, to evaluate precious stones, workshops on synthetic diamonds. That's done by the education department. I'm working mainly in the research department with respect to detection of diamonds, but also assisting other departments to help them out with special projects. And then, of course, important division or department is the equipment part, where one can buy instruments for polishing, processing, but also for evaluating and screening out diamonds, such as here the D-scope and the D-screen, which I will talk later on. Now, today's topic fits in the framework of color treatments and synthetics. It's nothing new to the trade, as such that it started long time ago in 16th, 17th century in Italy, where simple dyes were put on cut stones to modify the color. Irradiation with radioactivity took place in the beginning of the 20th century. And I would say the first appearance of synthetic diamonds took around the mid-50s. We come to the major two methods of producing diamonds: high pressure, high temperature treatment method and the chemical vapor deposition. These are two methods developed in the mid-50s. Then going along towards the 21st century, we had that major breakthrough of the high pressure temperature treatment for decolorizing diamonds. That was around 1990. And then more or less it became more complex. The treatment evolution consisted of combining different techniques to get a desired color. So you could order, knowing from your initial material what kind of color you get when you apply the correct recipe. of high pressure, high temperature annealing, radiation treatment with electrons or high energy particles, and then post annealing. Then somewhere in between 2005, people could have encountered those more advanced fancy colored coatings, producing again all different kinds of fancy colors. And then this year, I would say, although synthetic diamonds based on the chemical vapor deposition method were announced in 2001 by Apollo Diamond, it's only, in fact, this year that we encountered in the literature and the press the announcement of the major commercial breakthrough of these kind of products. And that's the main skeleton or framework where I would like to talk about you today. So first, if you look back at the definition of a synthetic diamond, it's very simple. It's diamond, meaning that it has the same physical and chemical properties as natural diamond, only the way it has been formed, not in Mother's Earth, I would say, but in an industrial lab environment, makes the biggest difference. But on a definition scale, it's diamond. So you have, according to IDC rules, different references in literature, but they all refer to diamond. It's very important to not state it as a fake or an imitation, because if we refer to imitations, we're talking about moissanite, cubic zirconia, and others. That's an example of polished yellow, fancy colored diamonds produced by high pressure, high temperature synthesis method by Genesis. So, meaning same properties. I illustratively listed out a couple of them. The same hardness, the same optical properties, the brilliancy. If you would cut or polish synthetic diamonds, would be possible to get the same sparkle, the same life, the same color as in a natural. The only major difference is the way they are produced. Normally natural diamonds are produced or can be produced at depths around 150 to 180 kilometers deep in kimberlite, volcanic. It takes a very long time, billions of years. Of course, if you want to produce synthetic diamonds, you don't have that time. It's only a week of production time, a few days. You want to have it commercially acceptable. Now, the major two methods for producing gem quality diamond at this stage are the high pressure, high temperature treatment method and the chemical vapor deposition. Now, for a long time, this method is well established since the 1780s, and you can see here the as-grown colors of such a method. So what you do with the high pressure, high temperature method is imitating Earth's conditions. So you mimic the high pressure, high temperature formation conditions of diamond. Starting from a small seed crystal, there is a carbon source, and then the building blocks, the carbon atoms, are sedimenting down on that seed crystal in that high pressure, high temperature region where diamond is formed. Producing most of the time yellow colors, because there is a natural nitrogen abundancy in the atmosphere. If you add special products, additives like boron in the growth atmosphere or environment, then you achieve blue diamonds. If you add so-called nitrogen getters like titanium, aluminium, and comparable, which is a very complex, tedious process, then one can achieve colorless diamonds. The main focus these days lies on the chemical vapor deposition. It's a technique that comes from semiconductor industry, and essentially what you do is add a carbon source, most of the time methane gas, hydrogen into a plasma, so it's high energy, high temperature environment, and what you do is also grow layer by layer in CVD reactor. How does it look like? Here are a couple of examples. To give you an insight in such a reactive environment, this is the plasma. The sources, like the gas sources, are fed like on different sides. Plasma is generated, for example, with microwave energy, and then the diamond is grown layer by layer on the substrate. Most of the time one uses a high pressure, high temperature synthetic diamond. Most of the time these synthetic diamond layers are grown for electronic optical devices like laser windows or base components in electronics. Now, if you look at the as-grown material, rough or as-grown for synthetic material, the differentiation is quite easy to make, because you're all, I assume, quite familiar with these kind of shapes, octahedral, perhaps pure, deformed, twinned shapes, but quite recognizable. Very distinct differences when compared to the as-grown CVD, typical trapezium, flat, layer growth structures, or the cubo-octahedral, high pressure, high temperature synthetic diamonds. An example for CVD grown diamond is that you also start from a high pressure, high temperature synthetic substrate, and then you grow the layer on top of it. Of course, this is bad quality, but then from this sample, for example, I do have the polished outcome here. So if you want to look at it later on, you're most welcome to see and to explore a bit. Other, let's say, indications that can point to CVD synthetic growth is that you could have some layered structure indications or pinpoints, but these only are indications. For conclusions, you have to go further. With respect to high pressure, high temperature synthetic diamonds, one can encounter remnants of the seed crystal, metallic inclusions, because the high pressure, high temperature synthesis method includes metal catalysts to facilitate the growth. Other indications can be like this kind of hourglass structures or under UV, typical green crosses. And these are all reflections from how these diamonds grow. And the way that these diamonds grow, one standard way for our lab also to look into that is using the Diamond View instrument. It's developed by the Diamond Trading Company, and it uses a shortwave UV illumination to get the surface luminescence. Not only color, but also the structure can be visualized quite nicely. And what is typical for a natural product is that it grows over a long time, gets deformation, and that results in quite irregular structures. Different colors perhaps. If you compare that with synthetic growth, you see it's very symmetric. For example, very typical high pressure, high temperature diamonds are very symmetrical. Cubo-octahedral symmetry is coming back. For the CVD, it's a bit different. There you have that plasma growth. It's layer by layer. And if you look closely here, you see that quite regular structure, or layered structure again. And that's for us, or for you, a clear indication, not a decision, for CVD synthetic diamond. Of course, that's our indications. What we within research do at HRD Antwerp for issuing certificates is then use a combination of more advanced techniques going from optical microscopy to other spectroscopy techniques to investigate, in fact, typical defects into the diamond, because they are the key to identifying the synthetic origin of these diamonds. Now, the last few years, since 2009, in scientific literature, there have been quite some reports on the improvement on the overall quality, the purity, and the use of these CVD synthetic layers. Not only colorless diamonds, but last year or 2 years ago, were also fancy colored diamonds present or being produced by, for example, Apollo diamonds, now referred to as CO diamond technology. Another clear indication is that a lot of companies like Apollo, now CO Diamond, and Genesis are really offering synthetic diamonds, CVD synthetic diamonds, HPHD, via their websites. That's a clear change with a couple of years ago. And then concern was raised or increased considerably in the media with the report on several hundreds of small undisclosed CVD synthetic goods in Antwerp. So that enforces, I would say, the need for reliable, fast and easy to use screening instruments for the sector. So of course you could install a complete lab with all the microscopy and spectroscopy techniques, but then you have also the people with the expertise in-house, and that's not workable, I would say, for the person or the institute or the companies as such. Now, to illustrate the difference between screening and detection is this diagram is, in fact, you want to refer the large majority of the stones as being natural, untreated, okay. You don't have to worry about these stones. If we talk about detection, then we have to be able to classify each stone as, is it a diamond or is it a simulant or imitation? And if it's a diamond, is it of synthetic or natural origin, like how it's made? And looking further into the color treatment aspect. Is the color natural or completely untreated natural? Note that at this current state, HRD is only issuing certificates for natural, untreated, untreated diamonds. So the color has to be natural. The only exception is for HPHD processed diamonds when properly disclosed. In all the other cases for synthetic diamonds, HRD Antwerp is at this stage following the policy not to certify these diamonds and clearly promoting natural gem diamond. So to give you an idea about how much work we have as research, we don't see every diamond. It's only like those diamonds requiring further investigation that pass after this screening stage that need further testing. So roughly it's 10% of the production. With respect to the screening, so far I would say you have two major screening instruments. It's the Diamond Shore, again a product of the diamond trading company, De Beers, and our product, the D-Screen. To refresh the minds, I would say Diamond Shore is working for polished stones. It's designed for cut polished goods, and it's, I would say, working restricted for colorless to near colorless diamonds. Of course, there is a size limit to it, but as you can see here in the new version, I would say there is the possibility to work with an optical fiber and to measure mounted goods on jewelry. Of course, there is a focus on colorless, near colorless diamonds, as it's based on the optical transmission spectroscopy principle. But the exact principles or working methods is not known because it's developed and patented by a diamond trading company. Then our product so far, D-Screen, is a much more faster, cheaper, easy to use instrument, but you have to know it's diamond. It works for the color rings D to J and in that size range. And what it gives, if it gives you a green light, then you know, if you know it's a diamond, then you don't have to worry, it's not synthetic, it's not HPHT processed. If you have an orange light, then you have to refer it to a lab, Chemicid or HIB Antwerp, or what we don't prefer, another lab of course, but to get the full detection and certification. At this stage, the goods that are coming through our lab, for example, they pass these two stages. The next step for research is to do infrared spectroscopy. And then at this moment, I would say we introduced this new derived solution on that area. And that's why I would like to talk about infrared spectroscopy and what it can do for you. So first start the principle, or it's a very, I would say it's a scientific technique, but I will take you through and hopefully it will make things clear or more have an idea what it can do for you. So it's a molecular spectroscopy technique, and if one takes the electromagnetic spectrum, then the color, so if you take light as such, what you can see, it's based in this region. So it's about how electromagnetic irradiation, radio waves, light sources can be positioned in as a function of energy, and that infrared region is if you have energies lower than the red light, so moving to the infrared light. UV light, it's on the other side, so it goes here. So what it does is you shine light with that kind of energy into your diamond, here visualized with that atomic molecule structure, and you look at the absorption or the amount of light that goes through. And what it does, it gives you information about the structural and chemical composition of your material. So you can differentiate between carbon and carbon, the building blocks of the diamond, for example, but also get information about impurities, because you're looking as such to vibrations into the building blocks, the atoms of your material. If you look at a perfect and a pure diamond, then if one irradiates the infrared light, you get this kind of typical curve. So it's very clean, very, I would say, simple, but and that is comparing to the light, the visible light region. So this is typical for a pure diamond. And why is this now important or interesting for us is if you put in typical imitations, like such as a cubic zirconia or a moissanite, then you see that the curves that you acquire or you measure are completely different. So it's very unique spectrum which allows you to identify a diamond. So that's the first plus, I would say, to identify it clearly, diamond or not a diamond. The other thing is the identification or acknowledge the presence of nitrogen and boron impurities. Now, why are these important? Does it matter which kind of impurities it has? Yes, fortunately it does. To give you an overview of the diamond classification scheme, it's something quite abstract. We make differences or a distinction between nitrogen containing and diamonds that do not contain nitrogen. As such, it cannot be measured because on a very small scale there can still be quite a bit of nitrogen present. And then you have the differentiation between different types. If you don't have any nitrogen, it's called type 2 or type 2b when it's containing boron. Type 2a diamonds are the most pure diamonds one can find in nature or can be produced in an industrial reactor. Why is that important? I come back to that later on. So how can you make the distinction between those types? It's just by looking at a certain region in that infrared spectroscopy, spectra, and then you get different typical features. Now, I don't know, but I would say this is very perhaps complex, abstract, and it normally is. So you need a lot of training, a lot of expertise for doing that. And that makes it not, I would say, straightforward to use it so far. If one compares then the very pure diamond, then you see that there is absolutely no features present besides the typical unique diamond fingerprint, I would say. Now, what's the benefit of using this kind of impurities and information? We'll show you that it's in fact a guide to the origin of the diamond that you're dealing with. And that we have seen that you can make that distinction based on the unique fingerprint between diamonds and simulants or imitations, but it gives you also indications that you might be dealing with synthetic diamonds. And then secondly, I would like to stress or illustrate the economic implications that are involved with the type. Most important for you is to see when you're dealing with colorless and near colorless diamonds, say the color range D to K or tinted color range, is that when you get the result from infrared or from the analyzer and you get a type 1A result for colorless near colorless, then in statistic terms, roughly 98 or 99%, depending on your statistics of course, is that these are colorless, untreated diamonds with respect to the high pressure, high temperature treatment or the colorless. These diamonds are not found synthetically and cannot be high pressure, high temperature enhanced, because if you would, for example, high pressure, high temperature treatment, then you would achieve yellow-green diamonds. We are talking about colorless to near colorless diamonds. Same accounts for 1AB. If then, in a similar approach, you can see that these can be HPHT treated. So these stones, if you encounter with the machine 1AB diamonds, you have to look further to check if this diamond is natural or HPHT processed with respect to the color and the origin of the color. And then type 2A diamonds, completely clear that these have to be referred anyway to a lab for further investigation. But at this stage, the good thing is that population-wise, only 1 to 2% of your goods are in that category, that range of goods that needs further testing. So that sums up a bit the use or the benefit that you can have. Now, of course, at this stage, you still have to think for yourself. And that's where we worked together with Broker, but that's the, I would say, new machine. The economic implications, of course, I don't have to tell you about the commercial difference when dealing with similants or imitations in a group of diamonds. That there are different or distinct commercial differences. But if one looks into the diamond population itself, I took the example of the Lesotho diamonds, well known for those big, large, high-quality goods. And assigning, for example, type 2A diamonds, you could think of using that for marketing purposes. Perhaps a long way around it, but I found, referring to prices, that they can go up. Typically these goods show good color, DE colors, and good clarity grades, making them very interesting to mine, but also to market and to sell afterwards. So what can infrared spectroscopy offer to you is distinguish diamonds from non-diamonds, imitations, and identify, screen out, or select those typical or selected types that you want to screen out for further testing, or if you're in one part of the business to treat diamonds, to select out those goods suitable for the treatment that you would like to do. But so far, as I said, you have to think for yourself. And that's the major drawback to the infrared spectroscopy technology so far, because major machines that we have in our lab look like this. They are taking quite a lot of space. They offer good results, but you need somebody who is experienced, who is trained to do it, and you need a lot of, I would say, infrastructure. There is a lot of delicate supply. But of course, you think it's a very interesting technique, it's non-destructive, it's relatively fast. So, somewhere in between. So that's why HRD Antwerp and Broker teamed up to develop on a based and well-proved hardware this new alpha diamond analyzer concept. The machine as such is presented here in front. You can see it later on if you want and have the demonstration. What it will do, essentially, it will offer you a reliable, fast and easy way to get to diamond detection and type classification. By doing that, or enabling you to do it for yourself, it offers you the possibility to create or boost the consumer confidence with your clients or whatever you would like to do for screening out your goods yourself. Because it's possible now for colorless diamonds to refer all goods, all polished goods, based on the reference of HPHT, synthetic or treated diamonds. Also for sorting activities, you can add the necessary added value. This sums up, I would say, because it's such a small, compact device, easy to use software, there the solution is that you don't have to think or have the expert in-house. And that makes it, I would say, a next step in your screening phase. If you're used to using D-screen or the diamond shore, for example, then now you have the possibility to have, let's say, our next screening step in the lab at your disposal. That's the main message. So it works, in comparison to the D-screen and the diamond shore, it works for all polished goods, for all colors. There is no size limitation anymore. As such, it's validated for 1 point and more. As such, you'd say, of course, there is a size limitation because you have a free height of 25 millimeters, but of course then you are working with 150, 160 carat stones, and that are not so common, I would say. And works for most common shapes. So the main thing is that can offer you, if you're dealing with these kind of issues and screening and selecting the right goods for further testing is crucial for you. We strongly believe that this is the solution for you. As an outlook for HRD Antwerp in providing and developing these kind of service solutions, I would be happy to discuss and to hear from you in what ways there are ways of collaborating for developing new solutions and offer in order to serve this community. Okay, we are Belgium based, but I would say globally to develop new things. And if you would have questions or you would see the machine in action, please come afterwards and I would be happy to show and demonstrate. If you have goods with you, you can test them. You have an idea. I do have like a few examples. I would say for more information you can contact me or like Thomas from equipment. And I remain you to thank you for your presence and for your attention. Thank you.
Muchísimas gracias.